Hey everyone, welcome to Lab 2 in Blood Bank. And today we're going to be building on some of the knowledge that we had from lab number 1, and we're going to be discussing in more detail reverse ABO typing. So before we get into that, this picture should look familiar. I just wanted to take a couple minutes and review Landsteiner's rule. It's very relevant to ABO reverse typing. Okay, so remember, Carl Landsteiner discovered that individuals possess naturally occurring antibodies which are directed against antigens that are not present, that they lack, okay, on their own red blood cells. Determining which ABO antibodies a person has is the basis of the reverse ABO testing, which we're going to be talking about today. The type determined through forward testing, this is so critical, must agree with the type you obtain from reverse testing. If they don't, if there's a mismatch, let's say my forward typing looks like A and the reverse typing it looks like O. That's a discrepancy, that's a mismatch. And so basically we would have to resolve what's causing that discrepancy. We can't guess which one is correct. And so when we get into lecture 5 and we talk more about the ABO blood group system, we will be getting into discrepancies and how to resolve them, because they actually do occur pretty frequently. Okay. So this chart should look familiar from lab 1, and we're just going to take a few minutes to review it again, because today we're actually going to be looking more carefully at reverse typing. So when we talk about Landsteiner's rule, okay, on the top row here, we show all of the blood group phenotypes and the antigens that are represented, if any, on the blood types. Okay, so you want to keep Landsteiner's rule in mind when you're thinking about which naturally occurring antibodies a person would have in their plasma. So when we have someone who's group A, they have the A antigen present on their red cells. So what that means is they're going to have an antibody to antigens they lack of the ABO group. So since they have A, they don't have B, we're going to expect them that they have an antibody against B. Okay. When we move on to group B, we know from last time these red cells have B antigen on them. Okay, what are they lacking? They're lacking A antigen, so they're going to have an anti-A. Group AB are those rare individuals that have both the A and the B antigens present on their red cells. What are they lacking? They lack nothing. So basically, they don't have any ABO antibodies in their plasma. And I will remind you of this again later, but this is why group AB is the universal plasma donor. So if we need to give plasma to someone in a transfusion, we don't know that patient's blood type in an emergency situation, AB plasma can be given to anyone without harm. Lastly, group O. We know group O lacks both A and B antigens. And what that means is they are going to have both antibody against A and antibody against the B antigen. So group O, we know from last time, is the universal red cell donor. Since they lack A and B antigens, giving these red cells to any blood group will not cause harm. Okay, and that's basically our wrap up. So hopefully that makes sense from last time. So I want to spend a few minutes talking about some ABO transfusion considerations, because the virtual lab activity that you'll be doing for lab 2 does have a component to it related to transfusion, and some of this I just mentioned on the last slide. So here in our very first column, we have different ABO and RHs. We're going to consider RH as well with this. Okay, and then we're going to see for each blood type, their red cells can be transfused to which other blood type, and then who this blood type can receive red cells from. Okay, So when we have someone who's a type A individual, they have A antigen, their A red blood cells can be transfused to a recipient who is also type A, okay? And so just remember, you can always get red cells of the same type, and so you're going to see that throughout, right? However, we could also give type A red cells to a person who's type AB. It's not going to cause them harm because this individual has the A antigen as well, okay? Now, what red blood cell types can a person who is type A receive from? Remember, you can always get your own type, which is A. And we're going to see throughout that O, as I mentioned on the last slide, is the universal red cell donor because O red cells lack A and B antigens. And so we can see that O can be given to anybody. Okay? When we have someone who's type B, their red cells can be given to another type B person or also to someone who is AB because the AB person has that B antigen. Who can type B person receive? What kind of red cells can they receive? Their same type, B, and O, which is the universal red cell donor. When we have someone who's type AB, AB red cells can only be given to another AB individual. We couldn't give AB to someone who's A because someone who's A, remember they lack the B antigen, they have anti-B. If we gave them AB, this anti-B that they have would basically bind to the B antigen of the AB and cause a transfusion reaction. So AB can only be transfused into another AB person. However, type AB can receive any of the blood groups. They could receive A red cell, B red cells, AB red cells, or O, the universal donor, since they have both of those antigens. Finally, with our ABO groups, group O, remember it's the universal red cell donor, so it can be given to anyone, type A, type B, type AB, or O without harm. However, when we have an individual who is type O, they can only receive type O. Let's think about why. Someone who is type O, we know, lacks A and B antigens. And if you think about Landsteiner's rule and from the previous slide, if they lack both A and B antigens, that means they're going to have naturally occurring antibody against A antigen and antibody against B antigen. So if we were to give someone who is type O, A or B or AB, we would surely kill them within a few minutes. It's not really funny, but their anti-A and anti-B is going to latch on to those antigens on those donor cells, and they're going to have a massive transfusion reaction. It's not going to be a good outcome. So hopefully that makes sense. I included in the chart also some information about RH. So we know from last time that the big D antigen is what we're testing for. And when someone has big D, we call them Rh positive. And 85% of the population is Rh positive. That's most people. So red cells that have that D antigen on them, Rh positive cells, can certainly be given to an Rh positive individual. Okay, we would want to, of course, take ABO compatibility into consideration. Okay. And I have a little superscript here. We would only, Rh positive red cells would only be given to someone who is Rh negative in certain emergency situations. And we're going to talk more about this when we get into the Rh blood group system. I don't want to move too far ahead on this now, but for now, just think we wouldn't want to do it unless we absolutely had to, okay? When a person is Rh positive, they could get either Rh positive or Rh negative red cells. Rh negative cells aren't going to harm anybody because they're lacking the big D antigen. So Rh negative can be given to both Rh positive and Rh negative, which is my next thing here. When someone is Rh negative, we really want to try to only give them Rh negative cells. And as I said before, in certain emergency situations, we can give Rh positive cells to someone who's Rh negative, but there are some extra steps that we take when this is done, and we'll talk more about that in the future. So this is a little bit of a review of what we talked about in Lab 1. So in Lab 1, we learned that forward typing, we use known anti-sera. We see anti-A and anti-B here to determine which antigens, if any, the patient has on their red cells. Okay. We use anti-D, which I don't have a picture of here, to detect the big D antigen. And remember, when someone has the big D antigen and their red cells would agglutinate with the anti-D, and that means they're Rh positive. We're going to add the reverse grouping into what we're focusing on for Lab 2. Reverse grouping, we're going to use known reagent red cells, A1 cells and B cells. And so these are red cells here that have A antigen, and B cells here have the B antigen. And we're using these known red cells to determine which, if any, naturally occurring ABO antibodies the patient has in their serum or plasma. And that's the basis of reverse typing. Okay? And so remember, when you're looking at reverse typing results, you want to reverse your thinking. This is telling us which antibodies the person has. Okay? So we want to make sure that forward and reverse agree, because as I mentioned to you all a few minutes ago, if they don't, we have a discrepancy. Procedure looks a little crazy. When we get together, I am saying we will get together in the fall for classes. We will have probably 2 blood bank labs where you guys can practice out these techniques. And forward and reverse typing is just routinely done together. Okay. So we're going to label 4 tubes for our forward typing. We have forward A, forward B, forward FAB, and our RHD tubes. And then we're going to label 3 tubes for our reverse typing, and we'd have our patient ID number on each one of these tubes. So for the reverse typing, we have reverse A, reverse B, and then we have something called the patient control. The patient control is basically run to make sure that the patient is not auto-agglutinating or agglutinating their own red cells, because if they are, it could affect any of these other tubes. We want to remember to always add serum source first, whether it's anti-serum or patient serum. And when we're looking at adding our serum source first, number 1, you guys know from last time that with forward typing, these are our known anti-sera. So our FA tube gets 1 drop of anti-A, FB gets 1 drop of anti-B. If we are using the anti-A, B, that's a combo reagent. We add 1 drop of anti-AB, and this is going to agglutinate when someone has A antigen and or B antigen, okay? And then anti-D. Okay, when we are doing reverse typing, the serum source is our patient's serum or plasma. And whenever we're using patient's serum or plasma as our potential antibody source, we double up, because patient's serum does not have as strong of reactivity as a reagent anti-serum. So it's 2 drops of our patient's serum or plasma in RA, in RB, and also in the patient control. Okay? Then we're going to add our cell source. It's either going to be our patient's 2 to 5% red cell suspension that we prepared with saline, or reagent A1 and B cells. Okay? So with our forward typing, as from last time, each one of these tubes has known anti-sera in them, so they're going to get 1 drop of our patient's 2 to 5% red cell suspension. Okay? When we move on to our reverse testing, this is where the reagent red cells are used. So that the reverse A gets 1 drop of A1 red cells, and the reverse B gets 1 drop of reverse B cells. The patient control, remember, we're just testing patient with themselves. So we're going to add 1 drop of that patient's 2 to 5% red cell suspension to that. Okay? So we're going to give them a little mix. We're going to bounce them in our centrifuge. We're going to centrifuge for 15 seconds at 35 RPMs. Take our tubes out in the same order in our rack. We don't want mistakes. And then we're going to read. And so last time I was talking with you guys about the importance of rack organization. and it's absolutely critical. So here you see a wrap that I set up probably last summer. And so basically what I want everybody to look carefully at is, you see I have patient 10 here. Every tube in my first row going this way is patient 10. I skip a row, and then my second patient 19 is in the third row. And I could skip a row and have another third patient in the back. Okay, I could have as many patients as I need, but this is the way we organize ourselves. So what do we have in this first column here? The original red cell tubes. Okay, this next tube here are the 2 to 5% red cell suspensions we made on each of these patients, number 10 and number 19. Okay, then every tube in this column are forward A tubes, 10 and 19. This column, it's the B tubes, forward B, so forward B for 10, forward B for 19. I have my forward FAB for 10 and for 19. And then I have my RHD for 10 and 19. And so that's all of my forward typing tubes as I have listed here. Okay. So I like to separate the forward from the reverse with my patient's serum or plasma. So here we see the plasma from number 10 and the plasma from number 19. And then for our reverse typing, we have our reverse A tubes, our reverse B tubes, and then our patient control. And so remember, organizing your rack in the same way every time is going to reduce the likelihood of you making any types of errors. And following centrifugation, take the tubes out and put them back in order before you start reading them with your viewing lamp. Okay, so let me just, I'll just review this one more time. So FAs, 1 drop of anti-A, 1 drop of anti-B, 1 drop of anti-AB, 1 drop of anti-D, 2 drops of patient 10's plasma in each one of these, 2 drops of patient 19's plasma in each one of these. Then we move on to our cell source. Okay, so patient 10, 3 to 5%, 1 drop, 1 drop, 1 drop, 1 drop. Patient 19, 1 drop of the 3 to 5% for that patient into each one of these. And then when we get into reverse typing, reverse A cells, 1 drop here and 1 drop here. Reverse B cells, 1 drop here and 1 drop here. And then we go back to that 3 to 5% patient, 1 drop into the patient control here, and 1 drop of this one into the patient control there, and we're all set. It's really kind of fun. You guys will get a chance to do it. Okay, so this picture should look familiar from last time. We want to read our tubes one at a time. We want to hold our tubes in such a way, I prefer to have the button in the mirror, and we want to mix once or twice and read. Mix once or twice and read, okay? And so this one here, we're going to review the grading reactions in a minute again as well. I would call this one a 2+ because there's not one big chunk, there's 2 big chunks and the background is clear, so I would say 2+. This also should look familiar from last time. Okay, so 1 big clump is a 4+, 2 or 3 big clumps with a clear background is 3+, maybe a bunch of smaller chunks but still with a clear background is a 2+, 1+, we have tinier chunks and the background is no longer clear, it's looking somewhat cloudy, and then completely in suspension, cloudy turbid solution is negative. And hemolysis, remember, can also be a positive reaction. Okay, so this is a great picture I found on the internet, which I love, love, love. Whoever did this, thank you. This is basically showing the expected ABO forward and reverse typing reactions for each blood type. Okay, so forward testing is telling us the antigen a person has on their red cells. When we have O, you see it's smooth suspension, no agglutination because O lacks A and B. So we reverse our thinking. If they lack both A and B, they should have anti-A and B that we detect in our reverse typing. And lo and behold, we have 4+ and 4+. So the anti-A reacted with the A1 cells, the anti-B reacted with the B cells. When we move on to someone who's type A, we see this beautiful 4+ reaction with the anti-A, negative with anti-B. What are they lacking? They're lacking the B antigen, so we expect them to have anti-B reacting with B cells. There it is, 4+. Anti-A is negative. I'm sorry, they are not they don't have an anti-A because they have the A antigen, so this one's negative. Let's move on to type B. Okay, B, we got 4+. B antigen is reacting with the anti-B. No A antigen, negative. So what antibody do they have? Anti-A. So their anti-A is reacting 4+ with these A cells. There is no reaction with B cells because they don't have anti-B because they have the B antigen. Lastly, AB, 4+ with both anti-A and anti-B. They are not lacking any antigens, which means we should not see any reactivity with A or B cells. They don't have any naturally occurring antibodies, and lo and behold, we get negative. Okay? So hopefully this wraps everything up for you and it makes sense. Very important to understand. So I'm going to stop there and I will talk to you guys again soon.